The final aspect of navigation involves returning data from a target screen back to the source screen. In this example, the first screen is the source. The user taps Enter Your Name, which opens a second screen where they can type their name. When the user finishes, the second screen is popped, and the Enter Name is returned to the first screen. Back on the initial screen, the button is still there, but now the UI also shows the name the user entered. To do this, we still build our screens as normal Flutter widgets. In this case, we plan to use navigator.pushNamed since we always push the same route. So we declare the two routes used by the app, one for the first screen, Home, and one for the second screen, Selection Screen. We also set the initial route so the app knows which screen to open first. The important part is the direction of the data flow. Pushing a route is what takes us to the next screen, but the data we care about, the name, needs to flow back to the previous screen. The home screen awaits the result, stores it in a variable, and then rebuilds the UI, so the entered name is displayed under the button. This is why Home must be stateful. There is something important we must consider. When the user taps Enter Your Name, we navigate to the second screen. In theory, the first screen has to wait for the user to enter the name before it can continue. If this waiting were synchronous and blocking, the app would freeze because Dart uses a single main UI thread. A blocking operation would prevent everything else from running, including rendering the second screen. Instead, Flutter uses asynchronous programming. When we call navigator.pushName, it returns a future. By using await, we pause the function, but we do not block the UI thread. The first screen is suspended, while the app continues running normally and allows the user to interact with the second screen. This does not mean Dart creates multiple threads. Asynchronous programming in Dart is still single-threaded by default. The difference is that asynchronous operations do not block execution. The function can pause and resume later when the feature completes. To define an asynchronous function, we use the async keyword. This allows us to use await inside the function body. So, asynchronous programming is a way to run operations that take time, like waiting for user input, without blocking or freezing the main UI thread. An asynchronous function returns a future. A future represents the result of a computation that has not completed yet. When an asynchronous function starts executing, it immediately returns an uncompleted future. That future remains pending while the asynchronous computation continues running. Later, the future will either complete with a value, if the computation succeeds, or complete with an error if something goes wrong. In Dart, future is a generic class. A future t means that when the computation completes successfully, it will produce a value of type t. To wait for a future to complete, we use the await keyword. The await expression pauses the execution of that function until the future completes, but it does not block the main UI thread. Now, if we go back to the important parts of the code, we can focus on the home state widget, which manages the state of the first screen. Inside this class, we define an asynchronous function called waitForName. which is used as the onPress callback of the button. The purpose of this function is to start the navigation to the second screen and then wait for the result. When waitForName executes, it calls navigator.pushName string and uses context and /selection as parameters. The string specifies the expected return type of the route. This means that the future returned by pushName will complete with a string value or null. This improves the type safety and avoids working with dynamic. Because the function is marked with async, it returns a future void. This is required since all asynchronous functions return a future. When the execution reaches the await keyword, the function pauses until the future from pushName completes. That completion happens when the user enters a name through the second screen. Once the result is returned, the function resumes execution. The return value is then used to update the state variable name, which is initially an empty string, and the widget rebuilds so the UI displays the entered name. The second screen, selection screen, does not introduce anything particularly new. It's a simple layout. We use a size box to limit the width of the text field to allow the user to enter their name. One small but important detail is that we use the onSubmitted callback instead of onChanged. The reason is that we want to return the value only when the user has finished typing and not after every single character. When the onSubmitted callback is triggered, we call navigator.pop context value, and the entered text is sent back to the first screen. Another aspect to consider is that in this case, the text field is managed inside a stateless widget. We will revisit this design choice later. As we have already said, we can clearly follow the different steps executed on a single thread. When navigator.pushName is called, it immediately returns a future. At that point, the function waitForName reaches the await keyword and pauses its execution. While waitForName is paused, the app navigates to the selection screen and the user can interact with it. The UI remains responsive because the pause is asynchronous and not blocking. The function waitForName resumes only when the future completes. This happens when the second screen calls navigator.pop context text, returning the entered name. At that moment, the future completes, await finishes, and the execution continues in waitForName, which then updates the state. For completeness, we should also mention that waitForName is marked with async, so it must return a future void. However, the onPress callback of a button expects a function that returns void. Dart allows this because the return future is simply ignored by the callback mechanism. After focusing on stack-based navigation, we can now move on to the other two navigation patterns.